This video is going to explain how to work with imaginary numbers. That is to say, when you have a negative under a radical. So before we do that, let's just review a square root, of course. The square root of 16 is 4, and that's because 4 times 4, or 4 squared, is 16. Now, what about the square root of negative 16? So what squared would ever give a negative? And the answer is nothing, right? There's absolutely nothing. We're going to need to define a new variable. We're going to call it I, and I is going to be the square root of negative 1. So anytime we see a negative under a square root, we can replace the square root of negative 1 with an I. So let me show you how we divide up this negative 16. We're going to divide it into 16 times negative 1. So this radical 16 times radical negative 1. Now, of course, the square root of 16 is 4, and then we just made this definition. We said that the square root of negative 1 is going to be written as an I. So that is our answer, and it's actually considered a complex number because it has a real number and an imaginary number being multiplied together. So let's work at simplifying a few more radicals. So here we have a negative under a square root, and that's going to be a problem. So we're going to strip out that negative 1, and then the 28 portion of it, I think of it as 4 times 7, and 4 is a perfect square. So the radical negative 1 comes out to be our I, because that's how we defined it. Then we have the 2 radical 7, because the square root of 4 is 2. So really the best way to write this would be 2I radical 7. 2I radical 7. Now in this next example, we have some variables under there, but we also have that minus sign. Now 64 is a perfect square, so it comes out as an 8. We have the negative sign under the radical, so that's going to come out as an I. Now we have 3 factors of x, so 2 of them make their way out, leaving 1 behind. And then y squared is a perfect square, so it comes out and there's no y's left under the radical. So there's the answer, 8I xy radical x. So some interesting things start happening when you take our new variable I and you start squaring it or cubing it. So I wanted to look at a few of these examples. So I squared means the square root of negative 1 squared. So what happens when you square a square root? Well, you just get the radicand, the thing that's under the radical. So this ends up being negative 1. Now what about I to the third? Well, remember, we just declared I squared to be negative 1. So this simplifies to be negative I, because we still have that I to the first there, so negative I. Now what about I to the fourth? You might think that's going to be negative 1 again, right? But let's think about it. We got I squared times I squared. So we set up above, remember we set up here, that I squared is negative 1. So we replace that with a negative 1. We replace that with a negative 1. The answer is positive 1. So anytime you see an I squared, just replace it with a negative 1. This would be I to the fourth times I. In the previous example, we said I to the fourth was 1, positive 1, and then we have the stray I there. So we're back to I again. So then I to the sixth would be I to the fifth times I. So remember, I to the fifth was I. So we're back to I squared, and what is I squared? Negative 1. So we've come full circle again, and the cycle is going to begin again. I to the seventh would be negative I, and so on. So in this first example, we're going to take 3I times 5I. Well, this is going to be 15I squared, and then what did we say? Anytime we see I squared, we replace it with a negative 1. So the answer is actually a real number on the real number line, negative 15. Now in this next example, we have 2 complex numbers being added. So I haven't talked about complex numbers. Complex numbers have a real part and then an imaginary part. So we often write it in the form a plus bi. That would be standard form for a complex number. Now, I always teach my students, just think about this as being combining like terms. So when we add these 2 complex numbers, we have positive 2 and positive 5. Those are our real parts. They add up to 7. And now combine the imaginary parts. So 3I minus 4I would be minus 1I. And that's the answer. That's where you stop. Now what about subtracting complex numbers? Well, just remember to distribute this minus sign just like you did back in Algebra 1. So we're going to have negative 3 minus I minus 2 plus 3I. So this whole thing, once we combine our like terms, will be negative 5 plus 2I. Now, multiplying imaginary numbers, specifically complex numbers of the form a plus bi, is really kind of interesting. You did this sort of thing back in Algebra 1 when you learned how to FOIL or use the box method, but watch what interesting thing happens here. So when we do the FOIL pattern, we get 3, and then on the outside we get negative 5i, on the inside we get 6i, so that is plus 1i, and then minus 10i squared. Now remember, whenever you see I squared, you replace it with a negative 1. So it's really 3 plus I plus 10. So the final answer is 13 plus I. So we multiplied two complex numbers, and wouldn't you guess, we got another complex number, 13 plus I. Here we have division of 2 minus 3i, that's a complex number, divided by the imaginary number I. Now, the trick here is to think about the denominator as being a radical. And remember, we like to rationalize denominators. So we get rid of the radicals in the bottom by multiplying by the number 1, something over itself. And if I multiply by I over I, what happens in that denominator? We get I squared. Well, that's awesome, because then it'll just become negative 1 down there. Now on the top, when we do the distributive property, we get 2i minus 3i squared. Well, there's another I squared. So on the top, we have 2i plus 3, right? Because I replaced that I squared with a negative 1. And we can go ahead and rewrite this as negative 3 minus 2i, because I distributed that minus sign on both of the terms on the top, and I went ahead and wrote it in the standard a plus bi format that complex numbers should be written in. If you recall, you had radicals on the bottom like this. You had to multiply by the conjugate, and that's what we're going to do here. It's called the complex conjugate. We're going to take and multiply by the number 1 again, but it's going to be 1 plus 2i, 1 plus 2i. That way it's the number 1, something divided by itself. Now I'm going to go ahead and multiply the two binomials on the top using the FOIL technique, and I get plus 5i plus 6i squared. Now the bottom, that's called a sum and difference pattern, so there will not be a middle term. And that's how we get rid of the I in the denominator. So simplifying this a bit further would be 1 plus 5i minus 6 all over 1 plus 4, because remember, anytime we see I squared, we replace it with negative 1. So this simplifies to be negative 5 plus 5i all over 5. Now you might think we just stopped there, but we do want to write it in our a plus bi form, so we split the fraction up. Negative 5 over 5 plus 5 over 5i. And then this particular problem really simplifies nicely. Negative 1 plus I. So that would be the complex form of that original division problem. And we divided by rationalizing the denominator, much like you did when you had regular old radicals that were not imaginary in the denominator. Be sure to comment down below on whether you have any questions about imaginary numbers, and don't forget to subscribe to the channel and like the video. All right, until next time.